So, so under collection, so first, if you remember, we actually started our all the sessions with something called data types, right? And we understood that when we want, you know, data to be saved, based on, same data type with the multiple values in it, right? So then we had one advanced concept called arrays, right? When you compare to data types, right? So moving one step ahead now, in arrays we have learned few concepts of how arrays behave, right? And what are the advantages of arrays we have over data types. Now we are going to see the limitations of arrays and see how collections normally do support us to overcome all the limitations. Fine. So when we talk about arrays, right, the size is fixed, first thing, right? So let's say if you create an array of size of size 10, right? Then it will always, the size of array will always stay 10. You won't be able to change it during runtime. So runtime changing of array size is not allowed. The size will be fixed, right? Your type of data will be fixed. If you create an integer type of array, right? Type of data, then once you fix the type of data, then it won't take up the other data types. Let's say if you are actually using integer, then it will not take strings and all, right? So similarly, you can see that these are the few things which arrays does not provide. So definitely here we will be looking about two things. One, dynamic size, which means you don't want to fix up any size, right? But as much as data you want to feed, you should be able to feed, which means it should be of dynamic size, right? And it should allow you to save any type of data, right? And as the last point, right, the memory size of arrays is also fixed. When we talk about memory, right, even this is also fixed, which means if you create any, let's say, array of size 4, right, then even if you are using all 4 slots or not of this array, right, the memory allocated for this array will always be 16 bytes, right? Because we know that integers are 4 bytes, right? And you have this 4 slots, array of 4 slots arranged, so the memory will be 16 bytes, which means even if you use it or not, it will eat up 16 bytes, right? So again, we need a dynamic memory allocation. So whatever we feed, it should allocate memory only for that specific data. That's it, right? And here, even if you remove it, for example, remove data, right? Then what should happen? Here, removing data is nothing but just nullifying it or making it 0, right? But it is not going to save the memory, and it is not going to shrink the size. But again, it should be dynamic. So the removal of data, as soon as I remove, the size should get shrinked. Similarly, the memory should get adjusted. So I mean, these are a few things which we definitely need, and you can see that if there is any entity which provides all this, right, then it's going to be a great feature. Your dynamic size, as much as data you feed, it should actually grow, any type of data, accept any type of data, and based on the data you're providing, allocate the memory dynamically. Right? It doesn't mean that when I say any type of data, it allocates memory for the largest possible data. No, if you are providing any type of byte type, like as small as byte, it should allocate only a byte. If it is actually taking any size of int, it should go only for int. That's it. Right? So based on the data you are providing, you should allocate. Right? Similarly, size and all. Now all these, limitations which we have in arrays, right, have got solved in our collections, right? So in collections, your size of collections is dynamic. Any type of data you can actually, use in collections. See, when I say any type, or you can restrict the type also. So we should have options for both. Right? Whenever you want, yes, we should be able to restrict the data. Yes, I want only decimal type. That's it. So decimals will be allowed. No strings, no booleans and all. Right? Similarly, if you want to make it open to actually accept any type, yes, it should be allowed. So it should be of from both sides. Right? So yeah, collections allow. There are different types of collections. Basically, two types of collections which allow restriction of data and which allow open type of data assignment, right? And the memory is completely dynamic. As much as you feed the data, it will allocate. Like whenever you remove the data, right, the memory will be freed up and it will be available in heap for other data processing, right? So these are the advantages or the limitations which are recovered in collections. So here, so basically we have two different types of collections. We have one non-generic collections. Now it's a non-generic collection and other generic collections, right? So basically here, see, when we say non-generic, now these are the type of collections which accepts, see, both type of collections have got all the features except type restriction. This is the only difference we have. So when we talk about non-generic, it will allow any type of data to feed. When we talk about generic, we have to provide a generic data type for which type of data to be consumed. We have to provide all those details. So that's the only difference we have. So let's start with non-generic. So in non-generic, let's look at array list. So we have something called array list, right? Class and the non-generic, right? Which accepts any type of data. So now here, see again, we are actually going in a step-by-step data types. We have seen each data type. When we talk about data type, which means whenever you define any data type like integer, right? Let's say I is equal to 10, right, or 1. What will happen? Right? A memory slot will be created, right, for integer, and the value 1 will be saved in it, right? And this is referred by a variable called I, which means the size of this slot is 4 bytes, and this memory is represented by I, and I is nothing but a variable of integer. This is what we have learned. And when we came to arrays, right, now we understood that I can actually create array of something. Let's say maybe I'll take short of size, let's say 3. So what does it mean? Which means I can say 3 different numbers here, right? Which means let's say I can say 100, I can say 200, and I can say some 300, for example, right? It means that there are 3 different slots, and each slot is of 4 bytes. Each slot is of 4 bytes here. Now this is something which is arranged arrays. Now in collections again, right? See, these are all upgrades. So arrays internally uses concept of data types. You can see, right? It's one data type, one single variable kind of. and it can save multiple same type of data. Now similarly in collections, when we come to collections, right, the inner pattern of data arrangement is same as arrays, where we'll be actually looking for, internally the lookup pattern, everything is arrays, but everything internally will be taken up by collections. Whenever you add data, it will automatically increase the size of collection and allows us to add data. Whenever you remove data, it will remove data and it will automatically shrink the size of your collection item. But all these things are automated in collections. That's the main difference here. So now let us see how we can actually use use collections to actually work with multiple data. So let me create a new project and let me call it as collections. Fine. So yeah, now we have here, let's say console.readline. So clear. Now, so here you can see it by default uses, it will import the generic, right? System.collections is the parent namespace we have where all the collection classes are defined, right? So under the system.collections you have generic option. So when you say generic, which means all the generic collection class will be there, but as we are learning the non-generic, right? So let me remove this non-generic, which means now this will take up only non-generic collection items. Right. So now let me give array list. So here you can see array list is a class under system.collections, which is a non-generic. So here I'm going to take, let's say, obj is equal to new, because this is how we normally define a collection object. Right? Internally, everything else will be taken care by the collection interfaces. So array list is something which is a non-generic collection. Now, so unlike our arrays, now how do we normally size arrays or actually take up the arrays? It is based on, we normally create array and give the size, right? Fix the size of array and then use it. But here you just have to create an object of that specific class you want. Now, as of now, as we are looking at a non-generic, now we are taking array list. Right? Now, so here let's first see how to add data, right? So every time whenever you see any type of arrays or anything, first thing is to initialize the class which we have done here and then feed the data, right? So now for adding data, it's altogether different how we are using arrays. In arrays, we always used to take array slot, which is index, and then we used to add data. But here you have a direct method. You can see, because as arrays is a class, right, which is derived from collections interfaces, right? Now it has got one method called add, where you can add any value. You can see as soon as I open it says object value. I can add any type of data to this array. So here let me add, let's say first thing, let's say I'm gonna add apple. I'm gonna add a string, right? So let me add more. See, as many as I'll add, it will automatically take up the data. I'll have obj.add up. Let's say I'm gonna give some decimal kind, obj.add up. Let's say I'm gonna use a boolean, right? obj.add up Let's say I'm going to give a some character D, right? Now you can see this is how we normally add data to collections. Adding data to collections we have, right? Now how to read data? Now reading data is again the legacy way. Console.write, let's say. Now for example, let's say I want to read the third value of my array list. So I'll be taking obj again. Reading back is again. So if you want to read each element, right, then you have to go to the index again. See, that's why. Sorry, I said internally. Even if you're using any collection item, internally everything goes through the array format. So I'll give 2. So now let me run this. So when I run it, object will be created and you can see all the data will be fed. And let me just increase the size, right? So all the data will be fed to 23.34 and then now you're reading back your data, which is at 7. Right? So this is how we normally take up the values here to read data. Now if you want to read all the details, let's say for example I want to iterate my array list and read, right? So that if you remember for each loop, right, while we were learning for each loop, right, we discussed that for each loop is something which is mainly designed for collections, right? Like because in collections, we'll have collections which are multiple types of data. We'll have collections which are specific type of data we will be getting, right? We'll also have data, right, which can grow or shrink. So here in for each loop we don't have to worry about the size of collections, right? Because for each loop doesn't look into size, it directly looks up the data, right? Create a lookup for the data and it will point each and every record of a collection item, right? So let me assign obj. Now you can see where is a variable type which will fit in any type of data in C#, right? Or else if you want you can also give object type, right? Either object or where you can mention anything, because array list is something which can take any type of data, right? So here while doing for each loop I have to mention either object type or a variable type right now. So let me print all the details, which is item here. Now this is how I normally iterate through my array list. Now you can see you have your apple 1, 2, 3 and so on. This is how we normally generate the iterate. And similarly, let's see more functions, internal functions we have in array list, right? So we have something called remove, right? So in order to remove data from these collection entities, right? That's what we learned, right? We can remove data. So here we can remove in 3 different ways. One, you can give object. The first remove, right, option is that you can see you can provide object. What object? You can give any value which you want to remove, direct value. Second, remove at. Remove at is nothing but you can give the position of that value. Let's say if you want to remove the third value, which means you have to provide an index of 2. Or you can remove some range. If you want to remove certain values, right, you can see you can give from which index till what count you want to remove. Let's say if I want to remove from second value, I want to remove 3, then you can give remove range from 1 to count 3. Then it will remove 1, 2, 3, 2, 3.34 and 2. That's we have as part of remove. So let's say I'm going to remove the actual object, for example. So what I'm going to do, let's say I'm going to remove something called true, right? So once I remove true, let's say I want to print it again. So let's say I have console.writeLine. Let me just give small break here, and let's say I'm going to say for each loop where item I'll give obj, right? So now when I run this, you can see the true is removed, right? So let's say for example, what if we don't have data and we're trying to remove, let's say obj dot remove of let's say some value, right? So let me run this. So here you can see when I run this slide, if data contains in this collection item, that we'll try to remove, right? This is important, guys. I mean, I'm talking only about non-generic collection items, right? When we go to generic, there are few collection items which if you try to remove data, if it doesn't have, right, then it will actually give you a memory exception, right? But here you can see when I'm saying remove 455, if 455 data is available in our list, yes, it will remove. Otherwise, it will not touch. Simple, but it will not crash, right? So this is our remove functionality here, where we are actually touching up the complete removal of it, right? And we have something called obj dot, let's see, reverse. So what I can do, I can reverse the data. You can see, which means I am actually reversing the positions I'm, right? From last to first I'm reversing. So the last one will become 0, 1, 2 and so on. That's a reverse. So you have a direct functionality of reversing using your collection items, right? And you have something called obj dot clone. Anyways, you have clear, right? When you use dot clear, right? So this is going to remove all the data. You can see here. Clear will remove all the details of your array list. It is not going to add anything, right? It will not keep any value. It will remove. It will flush out the complete, but still object will be there. It doesn't mean that object will be disposed. It will remove all the data as such. That's why you can see in for loop you're not getting it. So let me comment it because I don't want to put here. Now you have other functionality called clone. Very important functionality. You can see clone will create a shallow copy, which means non-reference copy of your array list, which you can save in other array lists, right? So which means I can actually create one more array list, like array list, let's say ABC is equal to your obj.clone, which you have to convert to array list, right? Now what is happening here when you loop on ABC? Let's say if I take ABC here, right, which means whatever data, right, operations you have in obj, everything will create a shallow copy. Shallow copy is nothing but your sorry, your obj will not be affected, right, but it will copy all the data of obj to ABC. See, let's say in ABC, after cloning, let's say if I say ABC dot remove of let's say what else we have, D, let's say for example, right, D, and let's say I want to print both ABC and let me just take this line. Let's say ABC I want to print and also I want to print OBJ. Let's understand how it works. See here. So I have created a shallow copy of ABC, and if from ABC I remove D. You can see when I'm printing data from ABC, there is nothing here, right? There is no D here. But similarly, you can see the OBJ is not affected. That's your shallow copy, right? It will actually create a copy of your array list which is not reference type, which means once you touch ABC, it will not touch your OBJ anyways. So that's why we normally create a copy of it, which you can do using the clone option. And then you have one more important thing. All these methods, whatever we're learning, are common across all the collections, right? All the collections almost. So we have something called contains. Contains is something which will give you Boolean return of whether the value which you are providing, let's say I'm going to give 1, 2, 3, whether this collection object contains it or not. Let me just print it. So contains 1, 2, 3, you can see true, right? Because yes, ABC still contains 1, 2, 3. That's why it will give you true, right? And if it doesn't contain, maybe let's say I'm going to give some other value and run it, then we'll see false because it doesn't have that value. So contains will check quickly whatever values you have. Now definitely see one or other functionality you may require based on your different requirements actually, right? So yes, we can actually directly use instead of actually looping on. See, generally what do we do, right? If you are in an array and let's say if you have 1,000 elements and if you want to find whether specific value is there or not, right? Then so immediately we'll try to write a logic, right, to loop on and check whether this value exists or not. That is not correct, right? Because it is going to hit a performance, right? So that's the problem there. So here mainly if we have a situation, right, then it's always better to use the internal methods of a class provided in Node. Fine. So that's your contains. Now similarly, you have let's say ABC. I'm taking ABC. You can take any. Anyways, you have copy2. Copy2 is again like a clone. I mean, you can actually. But if you are looking only for certain values to copy, you can always do that. So here you have few things now. From which index you want to copy, to which array you want to copy, right? Right. And from what array index to what count you want to copy. It's like a copy of an array, certain element of your array list or a collection to an array from which index to what index. That's your copy2 method does, right? So similarly, you have one more. Anyways, count, very important property. You have property you have. Let me just print. Count will always give you count of elements you have at that specific point. Right, it will retrieve a real-time count as such. You can see here count 3 because in ABC we have removed some more. In OBJ we have actually removed some more, right? And the final values we have 3, so that's why it will give you 3. This is your count of your collection item you have. Similarly, you have something called one more property you have. Index of, let me just show you that. Yeah, index of, very important one, right? So index of, if you want to, if you know the value, it's a straightforward like we have in strings, right? If you want to know the position of a value, right, then you can actually get it. Let's say you want to get the position of 1, 2, 3, and you can get console.writeLine of this, and it will give you the index which is 1 because 1, 2, 3 is the second value in my array, right, in my collection. So index will be kind of 1. So this is how we normally work with collections where we add data, remove data, get some more details about data, copy the shallows of data, check whether the data contains or not, and different stuff, right? And these items are common, or these properties and methods across collections are common. This is something which is your collection, which is a non-generic collection we have, and most of the time we'll be using our list for getting the details out. Fine. Now let's see how generic works. In generic we have few very important classes which we are going to learn. First thing is list, mostly used one, right? Your list. Now let's see how list works. Now anyways, as I said, for all collections except two, which is stack and queue, right, which we are going to learn now, everything else is same across all the collection items. So let me create a separate class here in collections. Right click and say add class. Now here let me create static void main string array. So here I'm going to say read line. Right. So here I am going to go with the list. Right. Now list is a generic collection class. Right. Now here you can see when we talk about generic, we have understood that we have to provide the type of data we want to restrict here. Right? For example, I'm going to give int. Now this is how you mention. In Angular basis, after the class, we normally mention the data type we want to restrict. List of int. Right? So I'm going to say obj is equal to. So this is going to allow only integer values to load. Right? Let's say obj dot. Let's say when I say add, you can see immediately it will say int. If you remember in our object, right? Let's say if I say something called obj dot add, see it will give you object because I can add any object I want. But it's a different case here. It will always restrict as soon as you give. So let's say for example if I give long, for example, right? Let's say I see here as soon as I create it, it will change to now everything else. I mean this list class, which is obj object of this list, will automatically set for manipulation of data based on long data. That's the cache, right? So let's say here you have 1, 2, 3, some values here. I'm gonna add, maybe I'll add sequential so that we understand. 100, 200, 300, obj dot 400, right? Obj dot 500. Right? So this is how we normally add. Now similarly we can route through and get it. So here, so let's say I wanna go for obj. Now here, so let me print it first. Console dot write line 5 item. Right? I'm gonna run this. You can see 100, 200, 300, 400. So that's your catch here. Right? So let's say for example I'm trying to add, I'll try to add obj dot add let's say some string. Right? Save it. So immediately it will give you a runtime error. Sorry, it is a runtime error. Right? It says again, let me open up this error list. You can see cannot convert string to no. Because you are actually providing a invalid argument type because it is looking for long and you are actually providing your string, which cannot happen. So you have to specify. And it is possible that if you want to provide data, yes, you can provide data in this way. It's not a problem. I mean here, there are different ways how you can actually make it happen, right? Yeah. I mean you can actually provide this. That's not at all a problem. So when you run this, you'll be able to see the string got converted to long. But end of the day, you are actually loading a long. That's important. Right? We are not giving any other data type here, right? But the long. That is something which is important here, right? You can see it here, which is a long data we have actually provided. Fine. So this is how your list works. Now where we are actually restricting the data and everything else is same. Let's say if I want, I can remove dot, let's say remove you have, and in removal, right, I'll have something called remove some object called